Stephen Whettingsteel is founder and CEO of Krysteline Technologies Limited, developer of specialized engineering solutions for the waste management sector, particularly in the recovery and refinement of glass. Krysteline has also developed an enviable reputation for high-quality refined glass suitable for cullet, cement, foam glass, fertilizers, water filtration, and expandable abrasives. Please.
Okay, good afternoon. Steve Whettingsteel, CEO and Managing Director of Krysteline Technologies. We're a British company, but we're a global reach company as well. So what we're here to talk about today, developing a sustainable glass recycling system. So one of the things that I like to get the most confrontational part out of the way early, constantly we hear this thing that glass is infinitely recyclable with no loss of quality, color, or any other things. Is that actually true? So you hear it in so many places around the world and so many environments, but we always have to question whether that's just marketing or whether it is the truth. So, going into perception versus reality again, we talk about what perception is. And of course, the marketplace, the public, all believe that when you take your glass to a bottle bank, it infinitely turns into cullet. There's no fine material, there's no wastage. It just miraculously turns back into a bottle, which gets back on the shelf. Is it true? Maybe, maybe not. So, cullet is the only true glass recycling. Again, on this message of reality. 100% of old glass can be sent to remelt. Is it true? Glass recycling at remelt is low CO2. Is it totally true? Furnace capacity and location will always match where that cullet is. Is that true? And is landfill daily cover of glass recycling? It's part of the mix. So do we really understand what glass recycling is? So have the marketeers grabbed hold of this message and made it something that maybe it's not? So these images show the reality of when you break glass, what happens. Earlier on in those earlier slides, we showed cullet maybe plus 10 millimeters. That's what we assume, but clearly you can see here when you break glass, you end up with lots of fine materials. So what happens to the glass that can't be optically sorted? So this is a significant proportion of the material that is in the feed stream. So we've got to start to look at what drives the system. What drives glass recycling? Is it legislation? Is it the value of the glass? Is it location? Is it some other factor? And quite often we hear around the world that there's fudging of figures and fudging of ideology. And that is glass recycling collection, reuse, repurposing? Marketeers have got hold of this message as well. So we constantly hear that the only true glass recycling is remelt. Who says so? So when we look at glass itself, and we've got those previous images of the interpretation that glass is cullet, we've got this fine material. Is it the collection mechanism that determines exactly what glass recycling is? We all understand what a bottle bank is. We understand the benefit of bottle bank. Generally, we end up with a cleaner glass. Generally, we end up with color segregated. But humans are involved, so of course there is some challenges. Curbside or source segregated, household collecting glass, also a really, really good source. But then we get into the scale of economics when we start to think about MRF glass. We start to think about in areas where there isn't a remelt facility. What about the cost of collecting the glass? So they've still got targets to meet, but they don't have a market. So they have to collect by the cheapest means possible. But then also commercial and industrial glass, the nightclub, the pubs, the restaurants, those types of things, where they may have staff that turn over relatively frequently. They don't understand the recycling system, and that's a challenge for the quality of glass. So how does that collection mechanism really determine the cost or the value? So we go back to those images and go back to reality. The first slide is what people really think bottle recycling is about. We miraculously end up with this optically pure material, same color. The reality of a bottle bank is more like the second slide. The third slide, we move into MRF glass. As you can see, it's full of putrescible waste. You can see that there's all sorts of other contamination. And industrial glass, it could be anything, because that could be from a bottle collection system. It could be from a packaging company that's depackaged food waste. So how much of that system above, the reality, can actually enter into the system? Of course, the first two can, because that's what optical sorters are designed for. The second two becomes more of a challenge. This is where we start to see significant losses. And we hear in the marketplace that, oh, optical sorters can do 10 millimeter minus down to 3 millimeters, but it has to be really, really clean and dry to operate at that size. So why is there such diversity in the feedstock? Again, the marketing is there that we put our bottle in a bottle bank and miraculously it goes round in the cycle. So is it the legislation around the world that's inconsistent? Do they actually know what recycling is? Is it the remelt industry that's giving them a message that cullet is the only marketplace? So we've got to start to consider how legislation determines the value of cullet. So also, does the collection method determine its use? So we went through those slides earlier again and looked at the cullet products. Yeah, pretty easy when the collection mechanism is bottle banks. But when the cost of bottle banks can be anywhere from 50 to 150 euros a tonne, you've got to question whether it's the right thing to do. And what happens when there's no remelt facility close by to where the glass is being generated? The claim, as we mentioned earlier, was that remelt is low CO2, but that is accounting for the CO2 when it's already delivered to the gate. There's no long chain CO2 attached to it. So there is a scale of economics about where the remelt facility is and where the glass is. And also what happens in areas where there's no remelt facility, but the legislation is saying the only true recycling is to remelt. We have instances where a client is shipping glass from Ile de Réunion, which is Mauritius area, all the way to France, because that's what legislation says should happen. You know, that's not good for CO2 for sure. So, as you can probably imagine, I'm going to start to talk about the products that are not going to remelt. It's a little bit of a lead in there. 8 millimeter minus or 10 millimeter minus is generally considered to be the material that can't be optically sorted. So why can't it be optically sorted? It's generally because it's poor quality. The size is too small, meaning that the optical sorter is not efficient. And also, within that mix of materials, there's around 40% of the incoming material in the marketplace which is less than 8 millimeters. And again, remember that message that all glass is infinitely recyclable. How can it be when 40% is less than 8 millimeters? Where does that material go? So the recycling industry and the governments have worked together to say, okay, landfill daily cover is a good use for glass. It's disastrous, isn't it? We're putting this material, which has a CO2 footprint attached to it, straight into landfill. What a crazy situation. So is it logical to suggest that glass recycling is cullet? Because it's determined the use of that 8 millimeter minus. the difficult truth. Now, this is actually much worse than I got up here. So, in the opening this morning, Dr. Kerman said there's 200 million tons of glass produced annually. And remember that 40% of the glass that is produced is less than 8 millimeters. So the figure's much worse than we've got here. But the reality is 39 million tons of CO2 is lost on that material going to landfill every year. So today and at every other one of these events, we talk about decarbonising the glass industry. We talk about changing furnace designs, other things. This is an awful lot of CO2 that's just being lost. And of course, at the moment, CO2 per tonne has a value of around $75 a tonne. So it's financially motivating to recover that material. And in lost revenue, turning that material into other things, 4.2 billion. So if you want a nice business case, this is one of the better business cases in the marketplace. And I've used the USA as an example because it's relatively easy to present about the USA marketplace. And this is the spread of furnaces or remelt facilities around the USA. And as you can see, the remelt facilities generally are not where the people are. So is that logical? Where are most of the remelt facilities located? Where the sand is. So why is that? So surely it makes sense for the owners and developers of remelt facilities that can now operate at up to 100% cullet to locate the facility at the location of the people, to ensure that we minimize the road haulage in moving that material to site, and to maximize the opportunity by getting a better spread of remelt facilities to include applications like glass fiber and these types of applications. So the USA is not unique. We see this all over the world. Sand was the original implication to putting a plant in a particular location, but as we move the mix from sand to cullet, we obviously have to rethink the location of those plants. So, can a furnace really run on 100%? I heard yesterday we can, which was an enlightening situation. But of course, if a furnace is running on 100% cullet, we've lost 40% of the potential cullet because it's too small. So we've got to create 160% of the cullet to go in that furnace. But also, the colour mix is wrong. So one of the big issues we see is feedstock security. So we're talking about lots of material disappearing in the marketplace. We're talking about the challenges of sand. China is running out of sand, or almost totally out of sand. So it's vitally important that our strategy is to recover 100% of the cullet and monetize that product to ensure that whoever runs the furnace or the remelt facility creates enough revenue from the 8mm minus to offset the extra costs that will be there as cullet prices increase, as sand becomes less available. So we also move into the part of the presentation about CO2. So should CO2 be attached to all waste products? You know, we talk about decarbonising, but we don't talk about long-chain CO2. So if the industry got involved in understanding the whole movement process of glass, so from the day it's produced, haulage to site, filling, to the public, various other locations, there's a long-chain CO2 value there that the industry could benefit from. And going forward, we feel that CO2 should be the driver in monetizing cullet rather than just making assumptions. So again, jumping back into the USA, something again people don't understand is that there is no balance anywhere in the world where there is the right amount of remelt facilities against the glass that arises in that country. The USA has a total glass arising of 12.5 million tons and around 5 million tons of remelt capacity. What happens to the 7.5 million? Where did it come from? So you've got companies like Thai Glass Industries and Yanlongji that are importing glass directly into the USA for filling. You've got imports. But the strategy in that country is 100% of glass has to go back to remelt. Is it no wonder that this whole system fails? So it's the same in most countries. So is it logical to suggest it's closed-loop recycling for remelt? So when we look at the valuation of cullet, we've got to consider the risk of sand. Eventually it's going to run out. So sand determines at the moment the maximum cost that an industry is going to pay for that cullet. But in the future, that cullet value will rise. Cullet quality has always been an issue for the recycling company because it's a huge investment in optical sorters, thermal cleansing, and other equipment to generate a quality of product that suits the industry. So, you know, we've spoken a few times about the non-cullet being disposed of, but somebody pays that cost somewhere, whether it's the public through the collection system or whether it be through the remelt facilities or a recycling facility. So where can we make improvements? We feel that it makes more sense, same as Şişecam have done, to locate the cullet processing facility right alongside the furnace. Take out the road haulage. But most importantly, we need to respect and monetize all glass that comes to that facility, not just talk about the cullet. All of that material has a value. All of that material has a long chain CO2 value against it. So clearly, there is a value in recovering that CO2. So we've got to develop, support, accept the range of alternative markets for that 10mm minus material. And the industry as a whole, the glass industry, needs to get on board with this because the benefit of using that non-cullet material is that there's extra CO2 in the marketplace. So if we want to decarbonize the remelt industry, we have an opportunity to use that CO2 as part of the decarbonisation process. We've also got to ensure that the government are totally clear that we've got to decarbonise, but we've got to understand where the carbon is in the industry, rather than the marketeers saying the only place that carbon can be saved is at the gate of remelt. It's totally inclusive. We've also got to provide equipment which is wholly designed for multiple marketplaces. So the same as Şişecam are doing, they've got an excellent colour performance plant, but to add other equipment alongside it for making new and alternative products is logical. And of course, we've got to constantly invest in research and development. That's a given. So just bombing through these, this is the strategy on the left that most people are aware of. So the cullet is recovered that goes into remelt, the rest of the material goes to landfill, but we sort of ignore the cost. And these are pretty low values, but $60 a ton for landfill. A lot of countries are more than that. So if we switch that around and we add more technology to the plant, look at the difference. At the base level, you know, a sand for water filtration or expendable abrasives, we're at $120. So we're already $180 better off, plus the CO2 that we're going to recover. So what are those markets? What is that change from that $60 to the $120? So at Krysteline and a lot of other companies around the world, we've been working with universities and authorities to develop a range of products that are ultra-low CO2, that only take the material which is less than 8 or 10 millimeters. There's no rationale in taking cullet. So each of these products are ultra-low CO2. The cement, you actually recover nearly 4 tons of CO2 when you replace OPC with glass cement. We all know about foam glass and the efficiency and effectiveness of that product. We've got a new one that's hitting the marketplace now, which is glass-based silicon fertilizers. This is taking a powder, turning it into a pellet, putting it into grow bags, and we increase the yield of a plant by a factor of 4. So for countries like Brazil, where they've got food famine, turning their waste glass into fertilizer and increasing their food output, that's a pretty good situation for the CO2, but also for creating legislation and a strategy which is wholly inclusive. So I'm wrapping up now. So what's the point of my presentation today? I'm sure you're all asking this. Challenge the myth that 100% of glass is recyclable. I know it's hard to take because that's what we've got used to listening to. To consider a more inclusive approach, so 100% of all glass is treated the same way. Motivate government and industry to understand, be engaged, legislate, research and development. All of these things are important, but we have to understand the reality. Outline the opportunity in considering an inclusive strategy. So we looked at that $180 difference just now, but something like glass-based silicon fertilizer has around €1,000 a ton sale price. So it's not insignificant numbers. And I hope I can offer a voice of reason, somebody that isn't directly in the remelt industry, but somebody that has been in the glass industry for 22 years and has worked on developing a business which is focused on the material that the remelt industry can't use. And always we say, if technology is our future, then we will be well served by those who are leading the way. That's my presentation.
Thank you very much. Are there any questions for him? I'm also looking.
Good.
Okay, thank you. Thank you very much, Stephen.
Thank you very much.